Welcome to this final video of this course. In the second scenario, we're going to choose one of my favorites, that is roaming, which is very difficult to troubleshoot in real life. I'm going to give you some pointers on how to approach this problem and what to check, okay, so that at least your life becomes easy, because I've wasted many hours of my time troubleshooting roaming for different customers. So hopefully, if you can follow these points, you should be able to at least isolate the issue and know what's going on, right? So let's try to see. You know what, my handwriting is too bad. 1 minute, I'll just write that once again for you. Roaming. Now what to look at, okay? It's very much possible that roaming is a problem that you've already heard of, because I have not seen a network in my life which has not had a roaming issue, and I've had almost 12 years of experience. Every network that I've worked with directly or I've worked on directly, I have seen a roaming problem here or there somewhere. It happens because that's the most common issue that you can face, and it's a little difficult to troubleshoot as well, because in roaming you need to do a lot of things on the ground to figure out what's going on and where exactly is the roaming issue happening. Okay, so let's see what all things to check and where to look at. So the number one reason of roaming issues is very simple. The simplest one is signal coverage problem. There is just not enough coverage. That's it. Not enough coverage. And that is the number one reason, okay? Because when the network was deployed some years back, the customer maybe thought that this part of the building is not going to be used, so let's not put an access point there. Or the customer basically thought, what, we can get away with 3-4 less APs, let's save some money, and I think we'll probably work on the ground and see how things work out. But he just tried to save some extra money during the deployment part, but then he usually ends up spending more money and more time on that troubleshooting that issue. So these two scenarios are very common, so be aware of these things. And this is probably the first common reason, and it's gonna look something like this. So if I have a coverage cell like this and I have a coverage cell like this of 2 APs, right, and my client is basically somewhere here and it starts walking here, and now this is the place where he should decide, he should be getting signals from other APs, strong signals, so that he can decide to roam. There should be enough overlap like this, right? But there is not. So he reaches here and then the connection drops, right? So that's what, there's not enough coverage. As simple as that. Get more coverage there. The second reason, which is gonna be very resonating with this one, is the first one is excessive signal or excessive coverage. Okay, excessive coverage. Now adding a new AP to help improve coverage or performance on the Wi-Fi network seems to be the first step that we take, right? We want to make sure we add in another AP wherever there's a problem. That's going to solve the problem for us. No, that's not a good thing. Adding new APs could mess up the whole RF design. So do not add more APs whenever there is a coverage hole seen. Do not do that. It's going to mess up the entire RF design. Will mess up the entire RF design done. Okay, now how will it look like if you have excessive coverage? Now let's say I have an access point, then I have another access point, then I have another access point like this, and my client is somewhere, let's say first here, and then it starts to walk here. How does roaming happen? So when a client is moving towards the edge of the BSS of one AP, the client wants to basically try to connect to a different AP because he knows it's going out of the coverage cell, and he tries to look for an AP with a stronger signal and will latch onto that AP by sending a reassociation frame. That's the process. Okay, I explained this to you in a very high level, but that's what really happens in from the client's perspective. Now if at a time my client is seeing very strong signals from more than one AP and he wants to roam, what will happen? Two things can happen. One is there can be a delay in roam. because he's not able to decide which AP to fault to. Second, I can have disconnects. Why? Now my client here sees a strong signal from here. These are 3 APs, for example, 2 and let's say 3. My client sees a good signal from here, here and here. Now my client decides to go to AP number C or AP number 3. He'll hop onto this one. After 2 minutes, it will try to hop onto this one, then hop onto this one, then hop onto this one, then hop onto this one. The client will not be able to decide, the driver of the client will not be able to figure out that which AP to hop to. So it will start hopping to different APs, very frequently, which will cause random disconnects on the network near that area. Okay, I know a client initiates a roam when the threshold of that client is breached. The signal has to drop to a to a minimum value of X before it can initiate a roam. But sometimes we have seen clients misbehaving on the ground even when they have strong signals from multiple APs. Issues like delay in roam and disconnects can be very, very common in areas where we have excessive coverage. So do not add more APs wherever you think there's a coverage hole, and do not blast the APs at maximum power. Okay, do not do that. That's going to be very, very bad for the network and the clients on the ground. The applications that the clients are running will face a problem. The throughput issue will be seen. So all those things are going to happen. The next point that can be a problem if there's a roaming issue is simple. It's an AP misconfiguration, AP or WLC misconfiguration, right? Especially when there are multiple WLCs involved, when the client moves from one WLC AP to the other WLC AP, or multiple APs involved, it's possible that the configuration is not the same on both the WLCs. When the client moves from one AP to the other AP on different WLCs, the SSID name should be same, right? Otherwise it won't roam. The type of security should be same. The security credentials should be same. Again, very important. Security credentials should be same, right? Even the SSID, whether it's hidden or not, should be same. The SSID is called SSID transmission. This should also be same. So there are multiple parameters that should be configured same on both the APs on different WLCs, or for that matter both the APs wherever the client wants to roam. If the client moving from one AP to the other is seeing any difference in these parameters, it won't roam. It won't be comfortable to roam, because it knows probably the AP does not support what I'm supporting right now, so it won't roam there as well. So that is something which you need to look at for sure, becomes very important. The fourth reason which could cause a delay in roaming or could cause roaming problem is the re-authentication part. Mostly in our networks nowadays, the corporate laptops connect on .1x, right? EAP authentication is what they use, right? It's very common. Whether they're using PEAP or EAP-TLS or EAP-TLS or any other type of EAP, it's something up to them. But any EAP authentication, as we know, that when a client basically roams from one access point to the other access point, the process of EAP will take some time, right? And this can cause performance with some latency, or for some voice applications it can even cause some delay and choppy, and even a call can get dropped. So you've got to make sure when this entire roaming process is happening, the time taken should be less than 150 milliseconds, or some people say it should be less than 100 milliseconds. Now how can this be achieved? You've got to make sure that there is the right key caching mechanism implemented. This is going to make sure your roaming time becomes less than 100 milliseconds, because he doesn't have to re-authenticate once again. The authentication will be carried forward from one AP to the other if the right key caching mechanism is implemented. So when the client moves from one AP to the other, they just have to create the keys once again, the encryption and decryption keys. They have to create that once again. The entire authentication doesn't have to happen. So this reduces the time from 800 milliseconds approximately, or 700 milliseconds, all the way down to 150 or 100 milliseconds. Okay, so make sure you have this in place. Right now, the next point and the last point which I want to look at is, just to make sure I don't, usually doesn't happen, but just to make sure I check that as well. Hidden SSID. I do not want my network to have any hidden SSID. It has been seen with experience, over time, that clients do not roam well. Clients do not roam well on hidden SSIDs. So you don't want to do that. There are many disadvantages of hidden SSIDs on hidden SSIDs. So make sure you tell the customer that you should not be doing this. So some clients we have seen in the past, they have a problem when jumping to a new AP with this configuration. So if the SSID is hidden, the clients prefer not to roam to that AP. So make sure this is not done in the network. And usually it's not very common, but there are still some networks who have some hidden SSIDs. So try to educate the customer on why they should not have this hidden SSID, and why they'll be much better off if they go ahead and broadcast the SSID just fine, right? So I hope this was helpful. I hope you got some idea as to how to approach these issues, because these client slowness issues and roaming issues are probably the two most common issues that I have seen in my life, over a period of 12 years in every network in Wi-Fi. So I hope you got some idea as to how to approach them. But again, I would like to mention that anything else that you want to discuss about any other scenario, my LinkedIn is open. Drop me a message, let me know that you went through the course and you have an issue, you have a doubt. I'll be more than happy to discuss that with you on the call, or on the LinkedIn messages also, right? So guys, this was the last video of this course. Thank you so much for watching this. I hope you learned something, some tips and tricks around what to do with troubleshooting, and I hope you learned how critical RF can be in a Wi-Fi network, and how critical it can be to not to have the right RF settings done. How critical it can be that if RF goes wrong, a lot of things can go wrong in the network. So start with that. Whenever you approach a problem, start with that, and I hope you'll be able to solve issues in Wi-Fi in no time now. Thank you very much, guys. Thank you so much for your patience, and I'll be coming out with a new course very soon. I'll keep you guys posted. Thank you so much.